Good morning, I'm Dr. Huang. Today, I'm going to teach you how to use dimensional analysis method to solve stoichiometry problems. If a chemical equation appears in your problem, always use the chemical equation to organize the information. We put down 2.45 gram below potassium carbonate because when you read the problem, you find that 2.45 gram of potassium carbonate appear in your problem. We also put down a question mark gram below potassium permanganate because when you read the problem, you read how many grams of potassium permanganate are needed. At this point, if we organize the information this way, we are pretty sure this is a typical stoichiometry calculation problem. Because for any stoichiometry calculation problem, you will be provided information about one chemical and you need to calculate the information about another chemical. The information can be gram. It can also be moles, molarity, volume, density, or any other quantity that can be related to moles. Now we are done for the first step. Step 2. Put down what you want to convert from on the far left of the paper. We want to convert 2.45 gram potassium carbonate into gram potassium permanganate according to the instructions on the flowchart. We need to put down 2.45 gram potassium carbonate on the far left of the paper. Step 3. Put down the unit we are looking for on the far right of the paper. We are looking for gram potassium permanganate. According to the instructions on the flowchart, we need to put down gram potassium permanganate on the far right of the paper. You may have already noticed I put down a chemical formula behind the unit. The reason I put down a chemical formula behind the unit is gram of one chemical and gram of another chemical, they are different. They cannot cancel each other. Moles of one chemical and moles of another chemical, they are different. They cannot cancel each other. If we put down a chemical formula behind the unit, we can avoid miscancellation. Step 4. Put down all possible conversion factors. All stoichiometry problems need conversion factors from the balanced chemical equation. Since we want to convert potassium carbonate into potassium permanganate, we need conversion factors that include both of them. This is one conversion factor. This is the other conversion factor. The conversion factor from balanced chemical equation is very easy to find. 7 moles potassium carbonate. 7 moles potassium carbonate. 14 moles potassium permanganate. 14 moles potassium permanganate. I put down MOL between the number and the chemical formula. This will remind me this is the moles ratio, not gram ratio. To find the twin conversion factor, all we need to do is flip the numerator and the denominator. You will get the other conversion factor. Because we want to convert gram into gram, but the balanced chemical equation will give us the moles ratio. So we need to find other conversion factors that allow us to convert grams into moles. We already know it is the molar mass of the chemical. To calculate the molar mass of a chemical is very easy. We can look up a periodic table. To to find the atomic weight of each atom. Then we add all of them together. We will get a molecular weight of the chemical. Molecular weight and the molar mass are the same thing. The atomic weight of potassium is 39.10. We have 2 potassium atoms in the formula, so we multiply by 2. The atomic weight of carbon is 12.01. We only have 1 carbon atom in the formula, so we multiply by 1. 16.00 is the atomic weight of oxygen. We have 3 oxygen atoms, so we multiply by 3. If we punch all the numbers into a calculator, we get the number 138.21. This number tells us 3 different stories. For every mole of potassium carbonate, the mass is 138.21 grams. If you have 6.02, multiply 10 to the 23rd potassium carbonate, the mass is 138.21 grams. This number is Avogadro's number. It also means if you have 1 potassium carbonate molecule, or if you have 1 molecule of potassium carbonate, the mass is 138.21 atomic mass unit. Because we want to convert gram into moles, so we need conversion factors from the first equal relationship. And there are the 2 conversion factors we can get from this equal relationship. We can use exactly the same calculation method to find the molar mass of potassium permanganate. I'm not going to show you the steps. We can also get 2 conversion factors from the molar mass of potassium permanganate. This is one. This is the other. Step 5. Pick a conversion factor and multiply what is on the left side of the paper. We want to cancel gram potassium carbonate. So we need a conversion factor that has gram potassium carbonate on the denominator. This one should be the one we are looking for. Oh, sorry. This should be the one. Gram potassium carbonate and gram potassium carbonate, they are exactly the same. One on the numerator, one on the denominator. So they will be able to cancel. Can the unit cancel? The answer is yes. Do we get the desired unit? We get mole potassium carbonate, but we are looking for gram potassium permanganate. The answer is no. So we pick another conversion factor and multiply what is on the left side of the paper. Now we need this conversion factor now. Mole potassium carbonate on the numerator and mole potassium carbonate on the denominator. They are exactly the same, so they will be able to cancel each other. Do we get the desired unit? The answer is no, because you get mole potassium permanganate, and we are looking for gram potassium permanganate. So we pick another conversion factor and multiply what is on the left side of the paper. Can the unit cancel? Mole potassium permanganate, mole potassium permanganate. One on the numerator, one on the denominator. So they will be able to cancel. Do we get the desired unit? We are looking for gram potassium permanganate, and we have gram potassium permanganate. Good news, well done, bingo! All we need to do next is punch all the numbers into a calculator. 2.45 multiply 1 on top, divide by 138.21 at the bottom, multiply 14 on top, divide by 7 at the bottom. After we calculate using the calculator, the answer is 5.60. In order to earn the full credit, you need to show all your work. This and this are needed.